Today I want to talk about, I know the notes say half identities, but this video I'm going to specifically talk about double angle identities. And you can see the three double angles: 2 sine theta, cosine theta. Cosine of 2 theta is cosine squared theta minus sine squared theta. By the way, there are with this one. And then tangent of 2 theta equals 2 tangent theta divided by 1 minus tangent squared theta. So we've got a couple of processes here to help us solve. The first one, or the first part that we need to look at, OMG, is the quadrant that the triangle is in. And we're going to sketch it. And the thing about this is that there will only be one triangle here when we're dealing with working with double and half angles. So we have to find the missing side lengths. That's usually with the Pythagorean theorem. Then we have to determine which formula to use. Are we going to use this one? Then we're going to use the triangle to replace the value of sine of x or cosine of x or tangent of x ratios in the formula. The entire trigonometric value, the sine x or the cosine x or the tangent x, gets replaced with the ratio. No trig words are going to be left. And then we're going to simplify. And by the way, you can use Desmos. I am going to be using my calculator today on this particular video. So if we scoot down here actually let me do this here so I have room to write. And it says, use the given information to find sine of 2 theta, cosine of 2 theta, and tangent 2 theta. Write answers in simplest fraction form. So tangent of theta equals 4/3, and pi less than theta less than 3 pi over 2. Well, if you look back up to the first step, it says determine which quadrant we're going to be drawing a triangle in. Well, here is pi, and here, nope, that is not pi. Here is pi. Here is 3 pi over 2. We're going to draw our triangle. And then when we label it, theta is there, and tangent is adjacent. So opposite is across. That's going to be 4. This is the hypotenuse here, and then our adjacent is 3. And if you don't know this triangle already, then we use the Pythagorean theorem. 3 squared plus 16 equals c squared. 25 equals c squared. And when we take the square root of both sides, we get c equals 5. All of our identities, we need to know sine of theta, we need to know cosine of theta, we know tangent theta. We already know tangent of theta. Well, sine of theta here, sine is opposite divided by the hypotenuse, and cosine of theta is the adjacent hypotenuse. And luckily down here in the notes we already have values filled in. So sine of 2 theta is theta cosine theta. That's one of the identities from above, which I know you can't see it, but it's look up above in the box. So we fill this in. 2 times 4/5, which is what sine of theta equals. Cosine of theta equals 3/5. And then we multiply these together. So again, type it in your calculator, type it into Desmos, whatever works for you. 2 times 4 is 8, times 3 is... Again, now that we know the values, it's just a matter of putting them back into our formula. So cosine of 2 theta is cosine squared theta minus sine. So cosine is 3/5, but we need to square it. And sine squared is 4/5. We need to square it. So when we square it, we get 9/25, and we get 16/25, and 9 minus 16 is -7/25. Now, I didn't need the calculator on those two. Maybe you do, maybe you don't. I will use it on this last one. And if you have a fraction button, I recommend that you use it. But we're going to fill this in. So it's going to be 2 times tangent of theta. And I don't need it for there. And then down here it's going to be 1 minus thirds squared. So here, 2 times 4 thirds, it's 2 over 1, so we get 8 thirds. And then we've got 1 minus, when we square 4 thirds, we get 16 ninths. And when we type that into our calculator, again, if you have it's alpha y equals, and then I'm going to put the fraction in again. So divided by 1 minus alpha y equals, enter, 16 ninths, and we get negative 24 sevenths. So as we switch over here to the next page, we take a look at this. The tangent of 2 theta, and then it also has the half angles, but I'm going to focus on the double angles right now. So when we take a look at this, we want to draw our triangle, and I need to be a little bit more careful, but our triangle is going to be between pi over 2 and pi. So we can draw our triangle here. And what we're given this time is we're given that the cosine is negative 2/7. Well, here's theta, and cosine here is the adjacent divided by the hypotenuse. Since we went left, that's why I made that value negative. And the whole fraction is negative. This side over here is the opposite. It's across from the angle. What's across from the angle is the opposite. I am going to call this B in here, because if you remember from the steps on the front page, what we have to do is figure out all the side lengths of the triangle. Negative 2 plus B squared equals 7 squared. We get 4 plus B squared equals 49. We can subtract 4 from both sides. We get B squared equals 45. And then we can take the square root of both sides to get B equals the square root of 45. Which, by the way, that can be simplified, but I'm going to leave it like that for now. If I need to simplify it in a couple minutes, I will. On Adventum, you may or may not have to simplify it. But when we look at the cosine of 2 theta, again, I'm going to stick with my identity, which is cosine squared theta minus sine squared theta. And we know what the cosine is. It's negative 2/7 squared. And then I forgot over here to put my different values. Sine of theta is the square root of 45. And again, I do want to point out that we can simplify the square root of 45. We may or may not need to. And then the tangent, it's going to be the square root of 45 over negative 2. I'm going to write the negative out in front, which you need to be able to see. So there is that. But now that I know what the sine is, we can write this in here. So finally, we'll simplify this. Negative 2/7 squared is 4 49ths. What I did is I squared negative 2, I squared 7. Over here, again, just to make things simple, square root of 45 squared is 45, and 7 squared is 49, and then 4 minus 45 is negative 41. So we finish this video here with this last part here, tangent of 2 theta, which is 2 tangent of theta divided by 1 minus tangent squared of theta. We can fill in our values. So it's 2 times negative the square root of 45 over 2. And then it's going to be 1 minus the square root of 45 over 2, and it's a negative here, squared. So what happens on this part right here is that these 2's, there's a 2 on top and there's a 2 on bottom. You can type it in, but we get negative the square root of 45 here, which again we might have to simplify that. Down here we get 1 minus, and it's going to be negative squared. Negative times negative is positive, so we're going to get 45 because square rooting and squaring cancel each other out. 2 squared is 4, and then what can happen here, so this is square root of negative square root of 45, but if we do 1 minus 45 fourths, we get negative 41 fourths. And I'm running out of space here, but as we finish this, this is negative the square root of 45 divided by negative 41 fourths. Well, when dividing, don't ask why. Flip the second one and multiply. 5 times 4 over negative 41 gives us negative 4 square root of 45 over negative 41. Double negative gives us a positive, and I'm still pressed for space here. But as we finish this problem here, the square root of 45 does need to be simplified. So I'm going to come back over here to simplify it. And remember that it's 9 times 5 is what 45 is, and then it's 3 times 3 times 5. We need 2 of the same value to take out 1. So the square root of 45 is really 3. Got to be able to see it. Square root of 45 is really 3 square root of 5. So it's 4 times 3 square root of 5 over 41. Again, we had negative divided by negative, which was positive. And then we can finish here. 4 times 3 is 12. Square root of 5 over 41.